In this video, I'd like to talk a little bit about how to do some basic recursion in Excel. There are many ways to do this. I'm going to show you one of my favorite ways, and then you can kind of choose, or you can go out on YouTube and you can search for other videos. So in this case, what I would like to model is I would like to model x of t and y of t for this system of differential equations, and I'm just going to use a basic Euler's method. So what I essentially want to come up with is the x and y outputs for various points in time. So actually what I might do is I'm going to right click here and insert a column, and I'm going to put in a column for t for time. And so we know that we need to have an initial condition, and we also then need to actually specify dx and dy dt so we can get the next x and y. So let's just say I'm going to make up an initial condition. We're going to say 0. We'll just use integer values, 5 for x and 10 for y. Okay, and now we need to calculate dx dt. So the way I'm going to do this is I'm going to actually reference the x value and y value so that I can actually calculate the slope, which in this case for dx dt will be 2 times the value of x plus 3 times the value of y. So you can do a quick check here and see that 2 times 5 is 10, 3 times 10 is 30, and then 10 plus 30 is going to be 40. So we would expect to get 40 right there. And so what I'm going to do is I'm going to call this column, I'm going to give it a name. And I'm going to call this column, so what I'm going to do is I'm going to highlight the entire column, column B, and I'm going to give it a name. So I'm going to call this X, and I'm going to press enter. So in this little box here, this basically declares the name of a cell or a column. So this whole column is named X, but you notice as you click individual cells, you see the cell name changing. So you can name a cell or you can name an entire column. In this case, I've chosen to highlight the entire column and name it X. I'm going to highlight this column and I'm going to name it Y and press enter, and that names it. Again, the individual cells are not named, but the column is referred to as Y and the column here is referred to as X. So I'm going to do the same thing here. I'm going to maybe just call this DX. I don't want to call it dx dt. It's too long of a name to try to have to reference, because I'm going to have to reference these names within the cells. So again, I'll press enter. And then I'll highlight this next column. So the difference between highlighting a cell, you get the little plus sign versus the downward pointing arrow. And you can also name a row if you wanted to by doing the same thing except highlighting the row. And I'm going to call this guy dy. Okay, so what I'm going to do next is, I guess I didn't really need to call dx and dt. I really just want to not have to reference the individual cell. So to calculate dx dt, that's going to equal. So I'm going to type in an equal sign in that cell below dx dt. This is going to be 2 times, so you actually have to do the multiplication sign, x, and you can see that it highlights the entire column, plus 3 times y, and it highlights that entire column. And now I press enter, and it gives me the output. Now how does it calculate the output, since we were referring to x and y as being entire columns? Well, it knows, Excel knows, or by default it goes directly into the corresponding cell for the row in which we are currently in from the x column and the y column. You can think of these as x vector and y vector. And dy dt will similarly be equals negative x plus 4 times y. And this way I never have to keep track of cell names, I just have to keep track of what I've called my x and y columns. So I get 35, which is consistent because negative 5 plus 4 times 10, that's negative 5 plus 40, which is positive 35. And now what I want to do in the next cell is I want to, well, first of all, I want to increase t by 1 in each case. So I'm actually going to say in A3, and we need to program the first 2 rows and then we're done. So what I want to do here is I want to say equals, and I want to take the cell directly above it, which is A2, so you can either click it or type in A2, and I want to simply add 1 to that. So that's now a recursive function that's stored. So if I copy this cell down, and the way I can copy a cell down is either by right-clicking and clicking copy, or I can actually just and then pasting it below, or just dragging the corner You see the little box appear in that right-hand corner, dragging that down, and you'll see that auto-populates the next cell, and that's an auto-reference, so we're basically telling Excel to reference the cell directly above it and add 1 to it. Okay, well now what I can do is I have to take my X value, so I'm going to take this guy here, and I need to add to it the change in X. Depending on what my change in X is, I'm going to add a whole copy of dx dt. So because my t is step size of 1, I'm just going to add 1 copy of dx dt to it. But what you can do is you can actually specify a step size, for example. So let's just say, well, I wanted to kind of quickly show you here how you could directly reference cells. Over here, I'm actually going to specify delta t, which is basically just my change in t, and I'm going to specify it right now to be 1. So now what I can do is I can actually say, I'm going to call this delta t, just that one cell. I'm going to name it delta t, so that now over here in cell A3, I can say, okay, I want you to take the cell directly above, and I want you to add delta t to it. And so you notice that that references that particular cell. So I've named that cell delta t, so that if I decide to change it later on and I make it 1/2, then it adds a half. If I make it a quarter, it adds a quarter. And the beauty of this is that now if I copy this cell down, it will add a quarter from the previous cell above it to the current cell I'm in. So if I change this to 1, all my step sizes change to 1. And not only that, but now I can say, okay, what I want you to do, Excel, is I want you to take my current x of t, and I want you to add to it delta t copies of dx dt. So basically, if my step size were 1/2, then we'd only add half of 40, because this is per 1 unit rate of change. So I get 45, which makes sense because all I've done is I've added 5 to 40. And now I'm going to do the same thing down here. I'm going to say, okay, take my y of t value and add to that delta t copies of dy dt, and we press enter, and now it populates that value, so we can see that 10 plus 35 is in fact 45. And the beauty here is I can just drag these two cells down because I already have a formula for how dx dt are being calculated. So again, it's taking 2 times x plus 3 times y. Well, basically that's 5 times 45, which is 225, which is just right. And this one takes negative x, which is negative 45, plus 4 times 45. So that's negative 45 plus 180, which is 135, which in fact works out. Now I'm pretty much done here. All I have to do now is just drag this cell, the second row that we've created. Here we need to do stuff manually. Here I did what's called hard coding. I actually had 5 and 10 automatically keyed in, and then in the row below it, that's where I had I had a row consisting entirely of formulas. So now I can take this whole segment, and I'm going to just drag, or again, you can copy and paste that whole row, and I'll drag it down as far as I want to go. And so you notice that in this case, we're actually getting some fairly large values, which are basically shown in scientific notation. So now if I change my delta t, if I want to make it quarter step size, in other words, get more precise in my Euler's method, I just change that to 0.25. Notice that, of course, it doesn't go out as far along the t values because I'm only going in quarter increments. If I change that even further to 1/10 increments, now I'm only going up to t equals 3, but I'm getting very fine changes and recalculations of the slopes. And that's good. Having a fine gradient is important when you're doing numerical methods, but I could change this to whatever I want. It requires no extra effort on my part. Now, I guess you could say, well, the extra effort comes into play. Well, if I still want to go down to t equals 3, I'll need to, take this down quite a few rows as I go along the way. So that's how you generally do recursion. If you had more columns or you had more references, if you were using something like Runge-Kutta, you could create a column for K1, K2, K3, and K4, and create autoreferences in a similar fashion. So I hope this has been helpful.